In this video, we're going to examine the disjoint pieces of a three-set Venn diagram. Determine the regions that make up the following sets, and we're given a bunch of questions here. So first, let's just take a look at a three-set Venn diagram and how this is set up. This is U, so this means it's a universe, and we're looking specifically at the sets A, B, and C. Okay, each one of them has a circle. But observe that there are little Roman numerals in here, and they're representing the disjoint regions of the Venn diagram. So if we were just interested in A, there's 4 pieces for A. You could be only in A. This is in A and B, but not C. This is in A and B and C. And here you're in A and C, but not B. So we want to be able to determine for each of these sets what regions make up the set. And then also notice there's a region outside, region 8. Those are elements that are in the universal set, but not in A, B, or C. Okay. So first, we're asked to find the regions that make up C. So I'm going to use a highlighter. So here's our C circle. Okay. And notice these 4 regions are different in terms of A and B. However, if you were in C, you must be in one of these 4 regions. So that is 4, 5, 6, and 7. So those 4 disjoint regions make up C. The next question asks us for the regions that are not C. Okay? Well, you're either in C or not in C. So we just found the regions for C, so we could think of just eliminating these regions to find the regions that are not C. So that would be the regions 1, 2, 3, and 8. They're not in the C circle. So 1, 2, 3, and 8. Let's look at the next one. Now we're asked for the region that represents C only. So that means you're in C, but you're not in A or B. So C only means C, not A, not B. So again, here's our C region. And we said C was 4 disjoint regions, but what region or regions is only C? Well, notice here, if you're in region 4, you're also in A, so we don't want that. If you're in 5, you're also in A and B. And if you're in 6, you're also in the set B. So there's one region that corresponds to specifically only C, and that is region 7. Next question. We're asked to find A and B. So remember, and means intersection. Okay, and that's here's A, here's B, so that's where A and B overlap. And when we had a 2-set Venn diagram, this was just one region, but now that we're including C, there's 2 regions that are both A and B. You can be A and B and not C, or you can be A and B and also C. Since it's not referencing C, we would need to include both of these regions. So A and B is the regions 2 and 5. Next, we're asked to find the regions for A or C. So remember, or means union, so this is anything in A or anything in C. Okay, so here's A. So we want everything in here. Okay, so we're going to include 1, 2, 4, and 5. But we also want to include anything in C. So I'm going to circle C. Now, since it's or, we include the overlap. It's in both sets, both A and C, but we don't list them twice. So we just have anything that's circled now is in A or C. Whether it's circled twice is irrelevant. So basically, this is everything but 3 and 8. So regions 1, 2, 4, 5, 6, and 7. In the next question, we're asked to find A or C, but notice added on to that is and not B. So generally we'll read these from left to right. So we're going to start with A or C, okay? But then it also cannot be in B. So that means since it's an and, we can cross out anything that's in B, okay? So you could think of this including things that are not in B or crossing out things that are in B. Okay, so here's the B circle. Let's use a different color. I'm going to cross out anything in A or C that's in B. So not this one. That's in B. 2 is B. 5 is B. 6 is in B. So notice there's 3 remaining regions that are in A or C, but not B. And they are regions 1, 4, and 7. And finally, we're asked B and A or not C. So we're going to start with B and A. Then we have or, not C. So there's a lot of operations going on. So first we want to find anything in B and A. We've actually found this already. B and A is equivalent to A and B. Okay. And then since it's or, we'll add on to that anything that's not in C. So we have to find the complement of C, which we actually found up here. Okay. And we'll compare it to these two in just a minute, but let's kind of start from the beginning. So first, B and A, that's the regions 2 and 5. Now we also want to include anything that's not C. Okay, so I'm going to cross out, let's use a different color. I'm going to cross out anything that's not C, but I don't want to cross out anything in B and A because it's an or. So we're definitely including 2 and 5. Okay, now what is not in C? So this is our C circle. And we have these 3 regions. So I X them out because it said not, but these are actually the ones we want to include. You may want to circle them. We'll do a circle cross out. Okay, so this includes regions 2 and 5. Okay, that was our B and A. 5 is in C, but that's okay because we have or not C. And the other regions that are not in C that we haven't listed already are 1, 3, and 8. Okay. And another way to do this, just to reference back, let's use a different color. We had not C was here, and we had A and B here. So if we look at these 2 results and look at their regions and perform OR on them, that means we would take anything in this region, these regions, or these regions. So 1, 2, 3, and 8, do we have them? 1, 2, 3, and 8, check. Actually, I'm going to change colors again for A and B. And for A and B, we need 2 and 5. Okay. So we already had 2, but we also have to add 5 to our list. Okay. So that's another way to approach this problem, is to find these 2 regions or subsets and then combine them using OR.